Sometimes we have equations that we can't solve, like this one. Actually, I can solve this one, and so can you, but let's pretend we can't. So we've got no idea how to solve it. Now, there's other ways we could think about it. We could think, would it be easier if I thought about it as x squared plus 3x equals 1? No. Would it be easier if I thought about it as maybe like x squared is 1 minus 3x? Does that make it easier? No. What about x equals the square root of 1 minus 3x? Is that easier? No. Okay, what about like x equals 1/3 of 1 minus x squared? Is that easier? No, it probably isn't. And I could do this all day, right? I could just keep fiddling around with it and putting it in different forms. 3x is 1 minus x squared. And other things. Two of these that I came up with randomly are quite special. That one there and that one there. And the reason that they're special is they start with x. They're comparing x with something else. And I'm going to make another video where I explain why that's so special. In this one, I'm just going to show you how we use it. What we do is we set up a recurrence relation using the form of the equation that we've made with x equals. And a recurrence relation is where you take a value of x, so say we take x0, and then what comes out we call x1. And then we take that x1 and we put it back inside, and then what comes out we call x2. So x2 is 1 minus 3 x1, and x3 will equal 1 minus 3 x2, and x4 will be 1 minus 3 x3, like that. In general, this is how you'll see it written, xn inside and xn plus 1 coming out. And that's a recurrence relation, and that recurrence relation, when you keep going, is going to provide you with an approximate solution to your original equation, provided your initial starting point is somewhere roughly near the root. And in the other video I'll explain why, but in this video I'll just literally do an example because it's dead easy. Let's start with one that we do actually know how to solve. X minus 3, x plus 2 equals 0. So the answers are going to be x equals 3 and x equals minus 2. If we expand it out, pretend we don't know how to solve it, then we get this. And then say we fiddle around with it and say x equals x squared minus 6. Actually, I'll go with a slightly different one. Not that it particularly matters. Well, it kind of does, but it doesn't matter because they'll tell you which form to write it in. I'll do x equals the square root of x plus 6. And then that creates my recurrence relation, xn inside, xn plus 1 outside. Now I'm going to start with something near one of the roots. Oh, the roots are moving, but anyway, they're 3 and minus 2. So I'm going to start with x0 equals, I don't know, like 2.6. Let's see what happens. x1 would be 2.6 plus 6 square rooted, which is 2.9325756. x2 is going to equal that thing, 2.93, etc., plus 6 square rooted, which is 2.988741484. x3 will be that thing, plus 6 square rooted, 2.998122994. And the next one is going to be that plus 6 square rooted, which is 2.999687149. See what's happening? It's just already 2.9999, 4 nines I've got now, 4, 7, 8, 5, 8. Now we already knew, I'm just having fun now to be honest, 9991, okay I'll stop. We already knew that the answer was 3, but I'm just showing you that that is what happens. The iteration process does work. You start with something relatively near a root, and you just keep putting it back in. Whatever comes out, put it back in. Whatever comes out, put it back in, and it will get closer and closer and closer to the true value of the root. If we're pretty confident that the root is 2.99, say, to 2 decimal places, and we want to prove that, then we can use a sign change argument. If it is 2.99 to 2 decimal places, then it is not 3.00 to 2 decimal places, that would be the next one up, and it is not 2.98 to 3 decimal places, that would be the next one down. So what we're saying is that it's between 2.985 and 2.995. All of those things round to 2.99 to 2 decimal places. So what we'd do is we would do f of 2.985, the original function that we wanted to equal 0, so that would be 2.985 squared minus 2.985 minus 6, and see what we get. And then we would do f of 2.995, remembering f is the function that we wanted to be 0, the thing that we wanted to be 0, so that would be 2.995 squared minus 2.995 minus 6, and one of these should come out positive and one should come out negative, and a sign change proves that there's a root between those 2 points, which means that regardless of where it crosses over, doesn't matter where, it will definitely round to 2.99 to 2 decimal places.